Hi everyone, Quadian here. Chemistry with Quadian, it's our channel for chemistry students from all over the world. We will teach you every day about all of chemistry theory lessons. Subscribe our channel and press the bell button for daily lectures updates.
Assalamu alaikum everyone. Today we will discuss acids and base, and in acid-base chemistry we will discuss how conjugate acid and base pairs are formed and the use of curved arrow topic. To discuss the conjugate acid and conjugate base, that how these are formed, we will first have to discuss the Laurie-Bronsted concept of acid and base. Actually, Laurie and Bronsted are the scientists which gave the definitions of acid and base in such a way that they said acid is a species that donate a proton and base are the species that accept the proton. Consider this example in which HCl acts as an acid and water, is an amphoteric compound. It can also act as an acid as a base. You have to consider the second species. When the second species is acid, water will act as a base, and when second species is base, water will now act as an acid, because the reaction between acid and base pair take place. Now, proton will be acidic if it is attached to electronegative atom. More the atom will be electronegative, more the proton will be acidic, because there will be more difference in the electronegativity, more polarity, and more polarity mean acid can donate its proton easily because the partial positive charge on the proton will be strong then. Now consider the reaction between these two species. Acid, you have said that is a proton donor. So it will donate its proton to the base because base is a proton acceptor. So HCl, after donating its proton, will form chloride ion, and the water after accepting proton will be hydronium ion. Now, HCl after donating its proton will form chloride, which will call the conjugate base of this acid. And base after accepting proton will form hydronium ion, which we can say is the conjugate acid of this base. For acid there is conjugate base, and for base there is a conjugate acid. These are two opposite pairs. Whenever acid is strong, its conjugate base will be weak. HCl is a strong acid, so its conjugate base will be weak. And water is a amphoteric, this is a weak base, so its conjugate acid will be strong. So you can define this in a simple way, that a conjugate acid results when a base accepts a proton, and a conjugate base results when an acid gives up a proton, as you can see in this example. Now there is another way to define this, that whenever a conjugate acid is formed, there is an increase in the positive charge. Let's see here. This is an acid HCl, and the conjugate acid is when formed, there is an increase in the charge positive. Both are the neutral species. The one where charge is increased, that will be conjugate acid, and that where charge is decreased, that will be the conjugate base. When conjugate base is formed, there is a decrease in the positive charge. Consider the example between water molecule. Here two water molecules react together, and one water molecule donate proton and the other accept proton. The one that donate proton is the one, for example, and it is a base and it accept proton. So after accepting proton, it will form hydronium ion, and this one that act as an acid after giving proton will form hydroxide ion. Now water is a neutral compound. Here there is a increase in the positive charge, so it will be the conjugate acid, and there is a decrease in the charge, it will be the conjugate base of water. So you can simply tell which is conjugate acid and which is conjugate base after just looking at the charge conjugate. Increase in charge is the conjugate acid, and decrease in charge is the conjugate base. Now consider this example. Can you assign the name acid, base and conjugate in this reaction? Yes, we can assign this. This is one species and this is a second species. In the reaction, actually this is happening that this oxygen has an extra pair of electron, so it has a negative charge on it. This lone pair is attacking on this hydrogen, and it will accept this hydrogen. So as it is accepting the hydrogen, it is the base, and it is donating hydrogen, it is acid. And here you can say that this is the conjugate acid and this is the conjugate base. There is a decrease in the charge, and this is a neutral species because here is a negative charge, and there is an increase in the positive charge because when positive charge is added, this negative is neutralized and it becomes a neutral compound. So we can say this is a conjugate acid and this is a conjugate base. Now curved arrows. We are using the curved arrows and in the acid base chemistry. What does curved arrows show? The making and breaking of the bond in an acid-base chemistry involve electron movement. We use curved arrows to describe the flow of the electron density. Consider this example in which B has a pair of electrons. This pair of electron is attacking of this hydrogen, which is the acidic hydrogen. Now this bond consists of two electrons, we know, and these two electrons both move to this species, and there is a bond formation between P and H, and this is the bond breakage, and only H with the electron as these two electrons are attacking on the hydrogen. So the arrow starts from these and end at the hydrogen. At the hydrogen we will draw the head. Now these two electrons are moving to this atom, so we will draw this arrow and end at the A. These curved arrows are actually describing the physical movement of the electrons. Means that these electrons are moving from the B and are ending at this H. And these electrons are moving from this bond to this species A. So, learning to draw the mechanism is one of the most valuable skills in the acid-base chemistry. You have to know how these curved arrows are moving and what does this curved arrow mean. Consider now this example in which there is a base and there is an acid. You know base accepts proton and acid donates proton. So this pair of oxygen is attacking on this hydrogen, and these pairs that is present in the bond, these are moving towards the oxygen. So H2O and this species with a negative sign is formed. Now you know that this is the base and this is the acid. After accepting proton, it will form conjugate acid, and after donating proton, the acid will form conjugate base. The base attacks the acid using a pair of electrons. The acid cannot lose its proton without the base taking it. All the acid-base reactions occur in the one step. These are the simultaneous processes that are occurring only in the one step. The mechanism shows two arrows indicating the two pairs of electrons moving simultaneously. One shows a bond breaking and the other shows the bond forming. Here the bond is formed and here this bond is breaking. Multi-step reaction mechanism is shown. Can you tell that which two steps in this reaction are proton transfer reactions? Yes, we can easily tell that which are acid and which are base species and which are conjugate acid and base pairs of these acids and base. Consider this in which this is one species and hydronium ion is the second species. Now this oxygen has lone pair. This oxygen attack its lone pair on the hydrogen, and this bond is now moving to this oxygen with the formation of water. Here oxygen is forming three bonds, so it have a positive charge on it. When these electrons move to this oxygen, this positive charge will be removed and water will be released in its normal way. And this oxygen, by accepting proton, it will now make three bonds and it has a positive charge on it. So as it is accepting proton, it is base, and it is donating proton, it is an acid. And after accepting, there is a increase in the positive charge here, so it will be conjugate acid, and there is a decrease in the negative charge because here we have positive and here we get a neutral compound. This is a decrease in the positive charge, so it will be a conjugate base. In the second step, there is no proton transfer, there is only the movement of bond, or you can say the movement of electron. This bond, which consists of two electrons, move to this oxygen, and water is formed, that is, and along with water this species will be formed. Now carbon is electron deficient here, so this bond will move here and will form a double bond, and this hydrogen will be accepted to this oxygen. Now tells that what are the acid and base in this reaction and what are conjugate acid and base pairs. Hope so you will now know that what are conjugate acids and base pairs. In the next lecture, we will discuss acidity and basicity and how we will quantify and qualify them. Thank you. Allah Hafiz. Kindly like our lecture and don't forget to subscribe our channel. Thank you.